Welcome, Algebra Lab students. We're going to look at the idea of solving a system of equations using substitution, which is something that you should have done in your algebra class already. So this should be a review for you, but I want to show you just kind of a quick reminder before you start your assignment today. So remember, to solve a system of equations, you can think of this kind of graphic organizer here. We are going to look for an equation that is either solved for y or solved for x. So we want to find an equation that says either x equals or y equals. And so I'm going to have to try to type a little bit today as we're doing this, just because my pad that I'm working with doesn't work very well. So we've got y equals 4. So that means that over here in the box, we would put a y, and in the circle, all we're going to do is put a 4. Now, on the next line down here, we're just going to write down this equation, but wherever I've got the y at, I'm going to put a 4 instead. So in this case, my other equation is 5x, and then it says minus y, but instead of writing the y, that's where I write the 4. So 5x minus 4 equals 6. Now the good news is, once I have written it like that, that is an equation that we've been solving since the beginning of the school year. So go ahead and solve that equation, and what do you get for x? Well, we would add the 4 over, and we would get 5x equals 10. And so once we've got 5x equals 10, then we divide by 5, and we end up with x is equal to 2. And so we've got the answer, x is equal to 2. Now remember, though, with a system of equations, you're always going to have an ordered pair for an answer. So you're not just going to have a single number like x equals 2. You're going to have a set of parentheses. And so for our ordered pair, we know that the x part of this ordered pair is 2. What's the y part of this ordered pair going to be, though? Well, we don't have to do a lot of work here, because it tells us at the very beginning that y is equal to 4, and so therefore our ordered pair would just be 2 comma 4. And so that's the answer that we want to use, is the answer that's got both an x and a y. Now, it's not going to always be that easy where the x or the y is just a number we have to replace. Sometimes it's going to take a little bit more work, and so let's look at an example like that here. And so in the next screen, we've got y equals 2x plus 5 and x plus 5, y equals 14. Again, we're trying to solve this system of equations. We're trying to figure out a value for x and y that makes both of those equations true. So to start with, we want to find a equation that either says x equals or y equals. So which equation are we going to use, the first one or the second one? Okay, we're going to start with the first equation because it says y equals. So y equals 2x plus 5. So now I use the second equation, but the trick is, when I get to the second equation, instead of writing a y, I write down 2x plus 5. So what that's going to look like is it's going to be x plus, now this doesn't say y, it says 5y. So I put 5, and then in parentheses, I put 2x plus 5. Okay, I'm not replacing the 5y, I'm just replacing the y. And so the y stays, or the y is gone, but the 5 stays. And then we still keep the equals 14. So that's a little sloppy there, but it says x plus 5 parentheses 2x plus 5 parentheses equals 14. Okay, again, that's a little bit more complicated than the last one, but it's still an equation that we've been pretty much solving since the beginning of the year. Let's go ahead and solve that equation, and what would you get? So the first thing we should have done is we should have distributed, and so when you distribute here, you get x plus 10x plus 25 equals 14. You subtract the 25 over, and that gives you negative 11, and so we end up with 11x equals negative 11. And so then when you solve, you get negative 1. Let me see if I can try that again. We end up with 11x equals negative 11 once we've moved things around. And so then when we solve, we get x equals negative 1. So in our ordered pair, we know that the x is going to be a negative 1. We still need to find out the y. Now, again, this one's a little bit more involved than the last one. We don't know what the number is for y, but we do know that y is equal to 2 times x plus 5. So since now that we know that x is negative 1, that means we know that y is going to be 2 times negative 1, because that's what x is, plus 5. And so what do you get when you take 2 times negative 1 plus 5? 2 times negative 1 plus 5, that'd be negative 2 plus 5, which gives you 3. And so our ordered pair would be negative 1, 3. And if we want to check and make sure that's a solution, we can do it like we did the other day in lab. We can just replace the x with a negative 1 and the y with a 3, and we make sure both of these equations give us true answers. And so if we put negative 1 and 3 into the second equation, we get negative 1 plus 15. Sure enough, that's 14. And in the first equation, we replace the y with a 3 and the x with a negative 1. We get 3 is equal to 2 times negative 1 plus 5. And that's true. So we do know we have the right answer here. Okay, let's try one more example like this. The next one has one little thing that we have to be careful about too. And so just want to show you that one real quick. So this one we have y equals 3x minus 2 and 5x minus 3y equals negative 6. So go ahead and which equation are you going to start with here? Okay, we're going to start with y equals 3x minus 2. And so we're going to put a y in this box, and we're going to put 3x minus 2 over here in the circle. And so now with the other equation, okay, the one that we didn't pick, that's the one that we're kind of using as our equation to start with. We would write 5x minus 3. But again, instead of writing the y down, we write down what's in the circle here. So we're going to write down 3x minus 2. And then that still equals negative 6. So if you were to take that equation and solve it, what do you get for your answer for x? Okay, so as we go through and simplify this, we would distribute first. And so again, the point I wanted to make here was just make sure you don't forget about that negative sign. So you're going to take negative 3 times 3x, which is going to be negative 9x. And so we are going to get 5x minus 9x, and then negative 3 times negative 2 would be plus 6 equals negative 6. Okay, so as we move things around, we end up with a negative 4x is equal to negative 12. And so we end up with the answer x is equal to 3. And so if x is equal to 3, what are we going to get for y? If we go back to our circle up here, we take 3 times 3 minus 2. That's 9 minus 2, which is 7. And so our answer just ends up being 3 for x and 7 for y. And again, if we wanted to check our answer, we could plug in 3 for x and 7 into y for both of those equations, and we find out that it's true for both equations. So we know we've got the right answer. Now remember, it's not always going to be a y equals equation that you start with. Sometimes there may be an x equals equation you start with, but you do it the exact same way if it's the x that equals something as opposed to the y that equals something. So that's what you're going to be doing on your assignment today, is solving these systems using substitution. If you have any questions about that, make sure that you either send me an email or get in touch with me through Canvas Messenger if you have any questions at all. So good luck. That's the end of our video for today. So that's all, folks.